Hello and welcome back to Calculus 1. This is the exam 1 review. So, what's on the test? Obviously problems, right? Now, which sections? We are looking into the chapter 1, which is a review and preliminary concepts. So, from chapter 1, we are talking about function definition. We're talking about graphing functions. So that's shifting and reflecting and everything else. We are talking about combining functions and function composition. So combining is when you add two functions, and function composition is when you plug one function into another. And inverses. Inverse function. Useful thing to know is difference quotient, let's say. So maybe I should just point this way. Difference quotient. Okay, stream might be going, I don't know. So for chapter 2, yeah, we have all of the sections. Now we did not work on 2.1 much or at all because that's 3.1 in terms of concepts for the secant line, tangent line. Instead of us dealing with these concepts section by section and trying to remember types of the problems, maybe it will be better, I'm doing it for the first time now, to kind of understand. We know chapters on limits, right? So you have that 2.7 thing which says definition. And then we realize that limits can be calculated by looking at graphs, doing the chart, or doing algebra. So both of these were in first two were in 2.2, the algebra one was 2.3. So 3 different ways to compute limits where graph and chart always work. Right? So that would be the biggest idea. Now, existence of a limit, which is that theorem 2.2. So left plus right limits. You know what I'm talking about, hopefully. So if the limit from the left, limit from the right are the same, then the overall limit exists. If they are different values, it doesn't. Vertical asymptote. Now, I see a lot of issues still, even though I made it clear, and you can go back and watch the stream, that pre-calculus thing, set denominator equal to 0, doesn't paint the whole picture. It's a big chunk of it, but it's not all. The definition, and when the problem in calculus says, figure out if something is asymptote, you must do the limit as x goes to that c of f of x from either left or right, plus minus, to get one of the infinities. You have to do that. For horizontal asymptote, again, definition. I have to put it lower. limit x goes to positive or negative infinity, and we are looking for a finite value, at which point, maybe over here I should say vertical asymptote at x equals c, and over here horizontal asymptote at y equals L. So all of these concepts, they work together. Then we have continuity. You must know three rules. F of a exists. Limit of f of x as x goes to a exists. And the third rule, limit x goes to a of f of x is f of a, which is completing this list of three. So that's the continuity. And we also have the, what else do we have? Intermediate value theorem, not a big deal. I have to worry about that. And then we have 3.1, which was find the limit of difference quotient. So mechanically, theoretically it's derivatives in chapter 3, but mechanically, right, from computation standpoint, it's 2.3. Now, there is a concept which I unfortunately skipped, and it's there on your homework, and it might show up. It's the squeeze theorem. So that one is fairly easy to understand because you're all familiar with the concept of a sandwich, for instance. So you have a piece of bread, have a piece of cheese. If you're allergic to cheese, put 2 slices. And then it makes you strong. And then put another piece of bread in between. It's also known as a sandwich theorem, actually. I'm serious about that one. So now, what happens here is, no matter where I take this sandwich, I'm always grabbing it for bread, right? That's how you handle a sandwich. No matter where you move this sandwich, the cheese that is trapped in between is going to go with it. Now, the same concept is applied in terms of the limit. You have a very nasty function that you don't know how to compute the limit for. None of the witchcraft we learned, well, obviously chart will always work. I mean algebraically, right? So you have this function. Now what you do is you figure out which function has lower values, lower y values than that one, and which function has the larger values, and those two functions that you know how to find limits for will sandwich the one that you don't. So if the limit of this is, I don't know, 5, and the limit of that one is 5, then the one that is squeezed in between also has to be 5. Because the sandwich, the cheese will go wherever sandwich goes. So if I squeeze the piece of cheese in between 2 pieces of bread, then that cheese is sandwiched in, squeezed in between. Same thing goes with functions. So for this squeeze theorem, which unfortunately I skipped, but we actually need it, is that if we have f of x, g of x, and h of x, such that f of x is squeezed in between g of x and h of x. So f of x is that bad function. And if we have that the limit of g of x as x goes to some number a is the same as the limit x goes to a for h of x equals some number L, then limit of the one squeezed in between, this case f, has to go to same L. Now, some cool examples of this. And the interesting part is how these problems are done. It's very systematic. You actually build the function that you are trying to figure out. So say you are trying to find the limit as x goes to 0 for x squared times cosine 1 over x. Let's say this is a function. Now, nothing works here that you know. You can't reason it because, yeah, I know 1 over 0 is infinity, but what's cosine of infinity? Cosine is oscillating, right? And it's not going to go shoot off or shoot down or just stay at 0, right? It's just bouncing like this. So which value does it take at infinity? So you can't use that reasoning. You can use that reasoning with e to the x. You have the graph for e to the x, and then you say, if the limit goes to negative infinity, answer is 0. If the limit goes to positive infinity, answer is infinity. So for e to the x, cool. Sine and cosine, not cool. Or tangent. So we don't know what to do with that kind of reasoning there. Can you do the chart? Sure, you can do the chart, right? You always do the chart. But then again, calculating cosines for all those values. And then say, well, okay, what is the way to do this? You build the two functions which will trap the function you want. You start from the idea that, and this is something that you should really note because it's going to be useful in Calc 2, 3, and later. You realize that the cosine of f of x is bounded by 1. Now, that is extremely important and powerful, very powerful. Now, that statement has absolute values. This statement means that cosine is sandwiched in between -1 and 1. Observe that I left some space in front of cosine, okay? So this means that. Now, I use my eyes to compare these. They're almost the same, right? So what I'm going to do is I'm going to just multiply through with what I'm missing, which gives me this. I'm multiplying here, so it's not x squared minus 1, it's x squared times -1. So I'm getting this. Now you see that our bad function here is sandwiched in between two easy functions, right? And our sandwich theorem says that if these easy functions on ends have the same limit, the one that is squeezed in between has to have the same limit. That's what the squeeze theorem says. So we know that the limit of -x squared as x goes to 0 is, and very good, limit x goes to 0 of x squared positive this time is 0. So what's happening with the middle one then? Yeah, they all say 0. So we make the conclusion using the squeeze theorem. Now this would be a good time to see the first time you use words to answer, right, the calculus question. You would say by squeeze theorem or sandwich theorem, if you call it either way. the limit of x squared times cosine 1 over x is 1 over sine, sine of 1 over x squared, or we can come up with technically anything. The goal, the trick is to build up, right? To build the function up from, here is the main concept, it's squeezed between -1 and 1, and then you just multiply through by whatever is there to figure it out. It should be fairly simple concept, and then just by watching this video, which hopefully is streaming. Come on, let's go. Yep, it's live. It doesn't show the picture there, but it's live. It should be, I think it should be good. Let me see. Come on. At least it says it's live, so we'll see. All right. So that's it. That's what we have for that sandwich theorem. Obviously, we're going to find 60,000 videos online on YouTube to help you with more examples. If I haven't talked about it before, the proper way to use YouTube videos to study mathematics is to start a video. Once the problem is displayed, pause it, do the problem to the best of your abilities, or up to the point where you get stuck and you don't know what to do. Then you play the video, check all the steps up to that point, see what's that one thing that is tripping you, pause immediately, continue, finish off the problem. That's the best way to learn with videos. You can't learn how to drive by observing someone driving. You have to go sit and drive. And technically anything in life, you have to keep trying. So if you just passively watch my lectures, if you passively watch videos on YouTube and examples, no one learns that way. You can't. Can't become experts by observing someone do things. You actually have to practice, you have to do it. So just, how many of you are professional bodybuilders? You watched the 2-minute video from anyone? No? Okay. It doesn't work that way. You gotta go over there and sweat and lift that awfully heavy stuff. It's bad. So yeah. Okay, now the second part of the review is, so I said everything. You know already what kind of problems. You all have the homework, whether it's book or online. The quizzes will start opening tomorrow, 6 a.m. What else is there? That post test for chapter 2, chapter 1 that are available on my MATLAB. You can practice that. There are review exercises in the textbook that you can work on for chapter 2. I believe I at one point had that on the display, or maybe did not. I don't know. But on page 123, easy to remember, is chapter 2 review exercises, and they're going to have about 100 problems, I hope. No, 60 something. 63 problems. Wonderful problems to figure out continuity and so on. And yeah. Any questions, concerns? Do you have any problems that you would like to see worked out? And if you have nothing to ask, it's lab time. Lab is due next class. If you have questions, we talk questions. Problems, let's go. What do you have? No problems?
Is there going to be slant asymptotes?
Most likely not. You do long division for that. And you can only have a slant asymptote if the exponent in the numerator is by 1 larger than the exponent in the denominator, because they will divide to a linear x. So there's only one case when they occur, and you can always get them by long division of 2 polynomials. And the reason why I said most likely not is because it's not really calculus procedure to obtain that asymptote. I just know we don't do the limit for it. No questions? Wow, amazingly clear. By stream. Maybe by stream.